Hey guys, so in this video we're going to talk about the basics of factoring trinomials that look like this. So x squared plus bx plus c. So basically you have a number here for b, you have a number here for c, and then you just have plain x squared. So we're really going into just kind of the basic idea with this. And to get started, where I want to start really is with a little warm up here, because this is a skill that we're going to be using throughout the video. So I just want to start by multiplying these polynomials. So this should be something that you're already decent at before you start this. So to multiply this particular set of binomials together, what we're going to do is we first multiply the x's together. So x times x is x squared. And then I've got the x times the negative 5. So this will be negative 5x. 3 times x is 3x. And then 3 times negative 5 is negative 15. So the thing I want you to notice here is in this particular case, we have like terms, so I can add the negative 5x and the 3x. So this will become x squared minus 2x minus 15. And so the thing I really want you to notice with this now is that this is a trinomial of exactly the form that we were talking about at the beginning of this lesson. So this x squared plus bx plus c, that is exactly what we have here. And the other thing I just want to point out is how this kind of factors. So this right here is actually the factorization of this. So basically what we're trying to do in this lesson is we're trying to take things that look like this and go backwards with them. Now, I want to do just one more example just to kind of finish getting us warmed up here. So again, maybe you want to just pause the video to make sure you're good on this, and this will get us in the right frame of mind. So taking the first two terms together, so this becomes 10x squared, and then I've got 4xy minus 5xy minus 2y squared, and then once again in this case I have these like terms here, so this becomes 10x squared minus xy minus 2y squared. And once again, this is still a trinomial. We're not going to talk about how to factor things that look like this in this video, but we will in other videos. And so just the thing I want you to notice, once again, we just have another trinomial here. Okay, so now let's talk about how to actually factor something like this. And we're going to draw off of that warm-up that we just used. And the method that I use in my videos is known as trial and error. So I do want to make a little note here. There are many ways to factor trinomials, so if you looked this topic up on YouTube, you'd find a couple different ways to do this. And I'm only going to use trial and error in this video, and I'm going to mostly push trial and error. So the trial and error method is probably like the hardest to learn at first, but once you get used to it, it is the fastest to use. So the other thing about trial and error is it's the easiest method to learn and remember, in my opinion. So all of the other methods, they have more steps that you have to do. This is a very basic set of principles that you have to remember. So you might not always get it right? There's the word error, so you might occasionally make errors. But once you kind of get the feel of it, it will go very fast. Now, as you move on to higher levels of math, speed with factoring is very important. If you are just using algorithms to try to factor all the time, I've seen other students do this and it just slows them down and it makes going through other math classes impossible. So this is why I push trial and error, because I don't want to slow you down in future math classes and I don't want you to forget how this works. So just a note on that. Okay. So back to this. So I want to factor this, and we've kind of already seen the structure from the warm-up. So the thing I want to point out one more time. So we had these trinomials, and then look at the form of how these kind of factored. So this is our goal, is to factor something that looks like this. So you've got two terms in one parentheses, two terms in the other parentheses. So that's exactly what I want to do here. So trial and error. We're going to set up two sets of parentheses like this. And there's really only like two things you have to worry about for the true trial and error method. So starting with this first term, so let me put just a little 1 next to it and I'll write a note. What two factors multiply together to get x squared? And that answer is going to go right here. So I will tell you kind of the punchline already, I guess. It's going to be x and x. like all the time. It's always going to be x and x. So that's kind of the freebie. And then the other thing that you have to think about is this last term. So let me just make another note here. So the only other thing that we have to think about are what two numbers multiply to get to 2. And when we figure that out, that's what we put in the other set of parentheses. So in this case, 2 is actually a prime number. So this is a very straightforward example because there's only one way you can get to 2. You have to multiply 2 and 1. So I put 2 and 1, and then I put a plus sign in between. Okay, so I made my guess, and now the way that I want to check this, so let me clear some space. So now what I do is I just take a moment to multiply all of this back together. So as I multiply, so we'll just do a quick little check here. So I have x times x is x squared, x times 1 is x, 2 times x is 2x, and then 2 times 1 is 2. So yes, this equals x squared plus 3x plus 2. Okay, so this is the whole idea, and all you really have to do is check it. But the thing about trial and error, the thing that you want to get really good at when you do this, is you want to be able to do this type of check. You want to be able to do it in your head. So let me just kind of illustrate how do you do something like that in your head. So first of all, if you followed the rules, you know that x times x, that gets you the first term, 2 times 1, that gets you the last term, right? So it's really just that middle term that you have to worry about. So what I always think of then is just multiplying kind of the outside terms and the inside terms. So look, I get 1x plus 2x, that gets me the 3x, so I can see that I'm good to go. So the way that I think through this, I think x times x, there's my x squared. I've got the 2 times 1, there's my 2. And then I've got x plus 2x, there's my 3x. So you have to practice this a little bit, but once you kind of get used to looking at it, you will get much faster at it, and then you won't even have to write all of this stuff out. Maybe every once in a while you will, but on the whole, you won't have to actually write it out. Okay, so I know this probably seems like a lot, but once we get really kind of cracking here, we're going to get through this very, very quickly. So let's take a look at one more example with trial and error. So here's something that gets a little trickier. So I'm going to set this up in the same way. So I've got my 2 sets of parentheses, and I always start by thinking, what do I multiply to get to x squared? So that's going to be x and x. And now here's kind of the plot twist, I guess. So what do I multiply to get to 12? Well, 12 can be multiplied together a couple of ways, right? I could do 1 times 12. I could do 2 times 6. I could do 3 times 4. So there's a couple different ways to make 12. And I just want to kind of, like you might already know what the answer is, but let's just think about this and like really think this through. So let's say for a second I decide to use 1 and 12. So I put 1 here and 12 here. Well, let's see what happens when I multiply this all back together. I get x times x, so that's my x squared. Then I have x times 12 and 1 times x. So you can see that that's going to give you 13x. So I've got this 12x plus this 1x, and then 1 times 12 is going to give me 12. So this gives me the wrong middle term, so that's not going to work. So you might already notice kind of another little thing about this, in that when you look at these factors, multiplying them together, you also want to think about which ones do you add together to get to the middle term. This trick works when you have x squared. It doesn't work if you have something like 2x squared or 3x squared. I'm going to show you kind of when this doesn't work out, but for this video, for right now, when you look through these pairs, one kind of stronger thing that you can do is you can look through and say which one of these pairs are going to add to the middle term, which in this case, I know that it's going to be the 3 times the 4. So this guess was wrong. Let me clear a little space. And now I'm going to have new guess. So this will be x plus 3 and x plus 4. So sometimes you might make wrong guesses. That's why it's called trial and error. But usually when you have the x squared, this is a very quick process to think through. So if I just want to check this in my head, so I've got, there's my x and x, there's my x squared, 3 times 4 is the 12, and then I've got 3x plus 4x, that'll give me 7x, so that's the right answer. Okay. So in this particular video, maybe it seems like it's straightforward, and that's great. That's exactly where you want to be. But I will just warn you, like, you can do things to this to make this a lot harder. So do keep in mind the general principle of we're always thinking about what do you multiply to get to this term and this last term. That's really what makes trial and error what it is. But because this is x squared, we can kind of mess with these terms to figure out more easily how to get to the middle term. Okay, so what I want to do now is I want to just practice this a few times. So I have two examples here. Maybe you want to pause real quick, see if you can factor them, hit play when you're ready. Okay, so for A here, I've got the x times the x will give me x squared. And then the last term is 5, so the only way to make that is 5 times 1, right? So then if I look at this, 5x plus 1x will give me 6x, so we're good to go. So very similar idea here with B. So once again, 11 is a prime number. So the only way that I can multiply to 11 is to take 11 times 1. And then if I check this, x times x is x squared. 11 times 1 will give me 11. And then I have 11x plus 1x, that gives me 12x. Okay, so let's move on to slightly harder examples now. And I do want to point something out here. So notice now that we need something that's going to multiply to positive 15 but add to negative 8. And something that's going to multiply to positive 30 but add to negative 13. So you might want to take a moment just to kind of think about this and then hit play when you think you've got a solution. Okay, so once again, so I'm going to have x and x. So two things that multiply to positive 15 but would add to negative 8. Well, if I multiply a negative times a negative, that will ultimately give me a positive number. But then, so let's see so this could be negative 3 times negative 5. So that would make 15, and then negative 3 plus negative 5 will make negative 8. So that will be how this particular trinomial factors. And again, if I just check it real quick, negative 5x times negative 3x is that negative 8x, so I'm good to go. Okay, so moving on to D here. So for this one, this is going to be, let's see, we've got the x's all set up. Two things that multiply to positive 30 but add to negative 13. Well, that'll be negative 10 and negative 3. And then once again, I can check negative 10x minus 3x will give me that negative 13x. Okay, so I have just a few more examples here. So this one's a little bit trickier. So now what I want you to notice here in these two examples, these multiply to a negative number. In the first case, it adds to a positive number. In the second case, it adds to a negative number. So you might have to play around with this a little bit. Pause for a moment, think, and then hit play when you're ready. Okay, so moving on to E here. So let's see. I know that x times x is going to give me x squared. And now I can think about what things will multiply to negative 24 but add to positive 10. Now, if you do want to make like a little list for yourself, you can always do that. So let's see. I could have like negative 6 and positive 4, or I could have something like negative 12 and 2, or I could have something like negative 8 and 3. So if you're stuck, you can always just take a moment to write down like these types of pairs and just think through them for a moment. And as you add them together, so if I were to add them together, like this would give me negative 2, this would give me negative 10, this will give me negative 5, so adding those pairs together. And then I can see, well, what I need is positive 10. This pair gave me negative 10, so if I just invert which one's positive and negative, that will get me the number that I need. So the way that this factors in is this will be minus 2 and plus 12. And so let's see, x times x is x squared. Negative 2 times 12 is negative 24, and then negative 2x plus 12x is 10x. So we're good to go. Okay, so for F here, so once again, I've got kind of everything written out. So if I think through this, let's see, I've got negative 14. That could be made by negative 7 and 2, and I can see right away negative 7 plus 2 will equal negative 5. So I can put in negative 7 plus 2. And then you always just want to take that moment to check afterwards. So negative 7x plus 2x, that definitely gives me negative 5x. So really scrutinize that. Okay, so for these last two examples, so now I just want to throw a little bit of a curveball in here of something that can happen when you're working with trinomials. both of these examples might look like they're very different because they don't start with x squared. But when you take a moment to really look at these problems, they actually both have a GCF. So in the case of G here, so notice that everything is divisible by 2. So I can factor the 2 out, and I will get this, x squared plus 8x plus 15. And then after I factor that out, then this is actually what I factor. So it looked like maybe this didn't have just a plain x squared, but actually once we factored out the GCF, it's still the same thing in disguise. So two things that multiply to 15 but add to 8, the way that this would look would be I'd have 2 times x plus 3 times x plus 5. So maybe you want to pause the video and just give this one a try and then hit play when you're ready. So in this case, so the GCF is going to be 5x squared, which when I factor that out, that's going to leave me with x squared plus 11x minus 9. Okay, and so now you're thinking, what two things will multiply to negative 9 but add to positive 11? So if I think about this, so negative 9, that could be negative 3 times positive 3, or that could be negative 9 times positive 1. And you'll notice actually that with both of these, neither one of these are going to get us to 11. So this is also just kind of the last trick note. So if you watched my video on the GCF, you might remember this term. This actually can't be factored any further, right? There's no way that you can multiply two things to get negative 9 that would add to 11. So every once in a while, you will encounter a trinomial that cannot be factored any farther. So this is actually as far as this particular one factors. A little bit of a curveball for the last problem there. And so that would be it. This would be all that we'd write for the factorization. And so that covers it for this video. So hopefully that was helpful. You got any questions, or if you want me to make other videos, you can always leave me a comment. I'm always reading and listening to what you guys want. Thanks for watching, guys. I'll catch you next time.